Hello everyone, and welcome to today's webinar. I would like to thank everyone for taking the time to join us here today. My name is Abdel Jabbar from the Grandstream support team here in Boston. So in today's webinar, we're going to talk about the GWN7600 series new features, and we're going to primarily focus on the Wi-Fi 6 that is going to be included in the next Grandstream GWN access point 7660. So before we get started, I would like to remind everyone that today's session will be recorded. So a copy of recording will be uploaded to the Grandstream YouTube channel. You should probably see it probably available tomorrow or the day after. And for today's presentation, if you guys have any questions, you can use the Q&A section at the right bottom corner of your screen. Can you guys just shoot me a message in the group chat just to make sure you guys can listen while there's no audio issues? All right, great. Thank you guys. All right, so we're gonna have a quick overview of the GWN7660, which is gonna be the next access point that is going to be released within a couple of months, which is gonna support Wi-Fi 6. We're also gonna dive into Wi-Fi 6 and explain the technology behind it. Then we're gonna go briefly over Hotspot 2.0 and explore some of the security features that were added in the latest firmware versions. Then we'll wrap up this webinar with Q&A. All right, so first of all, this is a product overview of the GWN7660. So as I mentioned, this is going to be the first Grandstream access point to support Wi-Fi 6. In terms of the look and the design, it looks similar to the GWN7600. And of course, it has different hardware, different memory, different CPU, which allows it, of course, to use Wi-Fi 6. And in terms of the specifications, this model supports 256 clients, concurrent clients, and it provides a coverage range of 175 meters. In terms of the aggregate throughput, you can get up to 1.77 gigabits per second. And if you look at the image, it breaks down how you get that aggregate throughput. So when using the 5 gigahertz and using Wi-Fi 6, you can get from 8 megabits per second to 1.2 gigabit per second. Of course, depending on which application you are using, the width of the channel, and so many other factors that are included to decide how much bandwidth you're going to get per user or per group of user. When using 2.4 gigahertz band, you can get from 8 megabits per second up to 573 megabits per second. This model also comes with a built-in controller that allows it to manage up to 50 access points in a slave mode. And this model also supports a multi-user MIMO technology. It has 2 antennas, and 2x2 basically means 2 for transmission and 2 for reception, and :2, it means the number of spatial streams supported on the model. And of course, it supports OFDMA. This is a word that you're going to hear a lot with Wi-Fi 6. And OFDMA basically works for both uplink and downlink. We're going to dive into details and explain how OFDMA works with Wi-Fi 6. So first, let's explore the new technology behind Wi-Fi 6. And before we dive into each element in this technology, so up to 802.11ac, the main goal of every new standards that has been released has focused on increased speeds and higher data rates to meet the demands of the applications that require higher throughput, and also to accommodate users in high density wireless environments. However, with 802.11ac, there are some drawbacks that prevented the legacy standards, including the legacy standards 802.11n together with AC, from achieving the advertised data rate. For example, 802.11ac promised a data rate of 6.9 gigabits per second, but in the real world and in the best conditions, you are more likely to get a maximum data rate of 300 to 700 megabits per second. And the main reason behind that is the spatial spectrum or the frequency bandwidth that is not being used efficiently. So while the focus of 802.11ac and the previous standards was to increase data rates, the focus of Wi-Fi 6 is to provide high efficiency by including a new technology in this standard. And in this slide, I have included 6 major enhancements in Wi-Fi 6 that are going to make the use of the wireless medium more efficient. So the first one is the multi-user MIMO. I believe some of you have already heard this word because it first came out when they released 802.11ac, but multi-user MIMO works different in Wi-Fi 6. So with 802.11ac, multi-user MIMO works only on downstream. In other words, if you have a 4x4 access point, the access points can send the traffic to 4 clients concurrently. But when these clients need to talk back to the access points, only one of them can talk at a time. So it did not support it for the uplink. And with Wi-Fi 6, now multi-user MIMO is going to work for both downstream and upstream. And the reason, the way multi-user MIMO works is that it uses the antennas, and each antenna represents a spatial stream. So it's going to use each spatial stream and dedicate it to one user so that it can communicate with that user. In some cases, it can use more than one spatial stream to talk to one user if that user has a large data payload. We're going to go into more details and explore the multi-user in the next slides. The next technology included in Wi-Fi 6 is called OFDMA. So in the previous or the legacy standards, we had OFDM, which works different than OFDMA. And OFDMA basically stands for orthogonal frequency division multiple access. And it allows the AP or the access point to communicate with multiple users by dividing the channel into sub-channels to increase efficiency. So instead of using the whole channel to talk to one user, the access point, and also the users, they can use a partition of that channel to communicate with the access point. And this allows the access point to send traffic to multiple users using different partitions of the channel that we call subcarriers. We're also going to explore OFDMA in more details in one of the next slides. Next is the 1024 QAM. Just for comparison, 802.11ac uses 256 QAM, which allows for 8 bits per symbol. And with 1024 QAM on Wi-Fi 6, each symbol carries 10 bits of data rather than 8 bits. And essentially, Wi-Fi 6 increases the amount of data packed per symbol, which theoretically should increase the data rate by 25% if we compare it with 802.11ac. The next technology is BSS Coloring. And BSS basically stands for Basic Service Set. And this Basic Service Set is an access point with its wireless clients. So when you have, for example, 2 offices next to each other, and each one is using their own access points, And when they happen, both of them to use the same channel, let's say both of them are using channel 6, we end up having what we call the co-channel interference. And in one of the slides, I'm going to explain how that affects uh, the wireless communication between the endpoint or the wireless stations and the access points. Wi-Fi 6 also now has a longer OFDM symbol. I'm sorry, these are two technical words, but there's no other way to explain Wi-Fi 6 without going through these technical terms. But in the next slide, I'm going to try to make it as simple as possible so at least you have a solid understanding of what makes Wi-Fi 6 better than the previous legacy or the legacy standards. So now they're using longer OFDM symbol, which increases resilience to multipath propagation due to longer guard interval. Some of you might already have used or configured guard interval on the access point, and guard interval you can look at it as a buffer. So when the access point sends a symbol or signal, those symbols might end up taking different routes depending on your wireless environment. So when they arrive to their destination, they might arrive with delay. So the guard interval is the period of time that is used to allow the client or the access point to wait for the other symbols in case they don't arrive in order. Next is the target wake time, or TWT, which is a new enhancement also included in Wi-Fi 6. This one did not exist in the previous or the legacy standards. And it essentially allows the access point to manage the client's activity by scheduling time intervals where the client can transmit traffic. And this mechanism, just by itself, is supposed to work with devices in power saving mode, and especially IoT devices that need to extend the battery life. So this one will apply mostly to IoT devices and devices that needs to use the power saving mode. But when the devices are in sleep mode, they reduce the contention header for the other devices that are not going to be using the same mechanism. So this is going to be also beneficial for all the devices in the same wireless network. So before we dive into multi-user MIMO and explain how it works, it is helpful and important to remind everyone how devices communicate over the wireless medium. And the first thing to always remember is that radio frequency is half duplex medium. In other words, wireless devices, including the access points, cannot transmit and receive at the same time over the same medium and the same channel. So wireless devices must always listen to see whether any device is transmitting and defer to send their data and wait until the wireless medium is available. And in 802.11 wireless communication, one of the methods used is called CSMA-CA, and CA basically stands for collision avoidance. And it is implemented, as I said, to avoid collisions over the wireless medium. So if you look at the image here in front of us, this is not using multi-user MIMO, by the way. We're not talking about multi-use. This is before using multi-user MIMO. So in this case, the access point can only talk to one wireless station at a time. And the other devices using CSMA-CA, they will defer from sending, but while waiting for the medium to be available, they actually create a lot of overhead. So each one of them needs to send what we call an RTS, or request to send, and they have to wait for what we call CTS, or clear to send. So when you have multiple devices waiting, that creates a lot of overhead. That's number one. And number two, it increases the airtime. So people have to wait longer to send their traffic, and the access point can only talk to one device at a time. So when using multi-user MIMO, this is what happens. So if you are using an access point that is 8 by 8, and I said that the multi-user MIMO uses the spatial stream to talk to a dedicated user. So if you have 4 by 4, the access point can only talk to 4 users at a time. And in Wi-Fi 6, the maximum that you can get is 8 by 8 with 8 spatial streams. So in this case, the access point is going to use each spatial stream and use it to talk to one user, which allows it to talk to 8 users concurrently. And user number 9 will have to defer from sending traffic and wait for its turn to send traffic. So that's the benefit of using multi-user MIMO. And in some cases, the access point can dedicate 2 spatial streams for one device to allow the device to send more data. So it uses a built-in algorithm to decide how to dedicate those spatial streams. So as I mentioned earlier, multi-user MIMO with 802.11ac worked only with down link. With Wi-Fi 6, it is expected to work for both uplink and downlink, which of course allows the access point to talk to up to 8 clients. For the GWN7660, because it has 2 antennas and 2 spatial streams, it can talk to 2 concurrent clients at the same time. And as I mentioned, it improves efficiency by using less airtime. So when the access point is talking to 8 users at the same time, of course, the wait time for each of these devices is reduced. And also this reduces the contention header. Instead of them like sending those packets to see if the medium is available. So while the access point is talking to them, they're not going to have to send as many contention headers. And one thing also to know about multi-user MIMO is that it works better with stationary clients and in low density wireless environments. So if you have mobile devices, probably a multi-user will not be implemented because it uses a built-in algorithm to measure the distance between the access points that it's, I'm sorry, to measure the distance between the wireless clients so that it can decide which ones to group in one multi-user MIMO. So the next one is OFDMA, which is supposed to maximize transmission efficiency. So before we look into OFDMA, let's look at how single-user OFDM works with legacy standards. So for the access point to communicate with users, the access point needs to use 1 transmission per user. And when it sends the transmission, it takes the whole channel. So for example, if there is one device that is sending a small packet, it could be like 256 bytes packet, it's going to use the whole channel. If you look at the image, for example, wireless user 1 is sending a small frame, and you can compare it to a container in a truck. So when you don't fill the container with deliveries or merchandise, you're going to end up having a lot of room that is not being used. So that's the same thing that is happening with 802.11ac. Is that for example, when you use a channel of 80 megahertz and the user is only sending small packets, that small packet is going to take the whole channel. And you're going to end up having a lot of frequency bandwidth that is wasted and not being used efficiently. And between each transmission, also there is contention header. It's like for user 2 and 3 to decide which one to send first, they need to send those RTS and CTS, like request to send and wait for clear to send. So that's a lot of messages that are being exchanged. And also the subcarrier spacing. So when you take the channel and you divide it into multiple subchannels, with OFDM, we get a subcarrier spacing of 312 kilohertz. In other words, we can't divide it into more. So when we go into OFDMA, you will see the difference. So with OFDMA, we can divide one channel into subcarrier spacing of 78, which allows us to have more subcarriers and eventually allows the access point to talk to more devices. So if you compare the two images, the difference is the access point, or OFDMA allows the access point to take one channel and divide it into multiple subchannels, what we call subcarrier, and then dedicate a group of subcarriers to a specific user. And we can use one transmission and send multiple data on each subchannel to each user. And of course, the access point is going to tell the users which subchannel they're going to need to use. And OFDMA, by the way, the same as multi-user MIMO, it works only when you have an access point that supports OFDMA and a wireless client that supports OFDMA. So if you are using, for example, your iPhone that does not support OFDMA, the access point will still need to use OFDM instead of OFDMA. So in this case, we have like a channel of 20 megahertz. So when using 20 megahertz channel, I believe you can the access points can subdivide it into 9 RUs, what we call resource units. And resource units is a group of subcarriers or subchannels. So with 20 megahertz, the access points can talk to 9 users at the same time. And as you can see, there is not much frequency bandwidth that is being wasted because we're filling up the whole container and sending the data. When using 80 megahertz, in case you want to use a wide channel, the access points can actually talk to up to 37 wireless clients. And of course, it uses its built-in algorithm to decide how to use those resource units. Sometimes it can dedicate more resource units to one user and dedicate, for example, a couple of resource units to other users. And of course, when you send more traffic to multiple users in one transmission, you reduce the contention header or the messages that the other wireless devices send to contend for the wireless medium. The next one is the BSS coloring. So with Wi-Fi 6, like I noticed that the IEEE now is using some different words like Wi-Fi 6, BSS coloring. BSS coloring, we're not talking about any colors. It's actually numerical identification. And if we look at the example that we have in the image, it's going to explain how BSS coloring works in such example. So when you have two access points, let's say you have two offices next to each other, and each one of them happen to use channel 6. So as I mentioned earlier, we end up having what we call co-channel interference. And in the example, you will see that user 2 and user 3, they happen to be in the co-channel interference area. So the AP1 is in BSS1 and AP2 is in BSS2. So if you look at the image at the bottom, this is what happens. When user 2 sends or transmits traffic over the wireless medium using channel 6, user 3, when it sees that user 2 is transmitting over that channel, it's going to defer from sending it. It's like it's going to wait for its turn to send, even if user 3 is actually connected to AP2. So they're not even in the same wireless network. And that is the case why you will always hear that if you need to run a Wi-Fi analyzer to see which channel the neighboring access points are using, so you can use another non-overlapping channel. But in most cases, you are in an environment where there are so many access points, and 2.4, for example, gives us only 3 non-overlapping channels. So in most cases, you're going to end up with the channel that is already being used by another access point. So BSS Coloring came to solve that issue. So if you look at the image at the bottom, this is how it works. The access point, now they're going to add a new header in the communication, in the management communication between the access point and the wireless client, so that the access point can tell the user, for example, AP1 can tell user 2, you are in BSS 1, and AP2 is going to include information about the BSS to user 3 to tell it you are in BSS 2. So when user 2 sends the traffic to AP1 and user 3 sees that traffic, it's going to read that BSS number, which is a numerical identification number. Then it's going to know that that traffic does not belong to the same BSS, and in that case, it's going to start transmitting instead of deferring from transmitting the traffic. And 802.11ax, by the way, 802.11ax and Wi-Fi is the same thing. 802.11ax is the standard, the name of the standard. Wi-Fi 6 is the common name for that standard. So as I said, it defines a numerical value in the PHY header or the physical header that identifies the intra-BSS transmission. And it is also intended to reduce the medium contention overhead. So instead of, for example, user here, let me go back here a second. So instead of user 3 deferring from sending and start sending those contention headers like the messages to request to transmit, now because it's allowed to transmit, it's allowed to differentiate between different BSS, we're not going to have those messages being sent in the network. And without BSS coloring, co-channel interference would create more airtime consumption. In other words, we're going to have more devices waiting for their turn to send. So for co-channel interference, sometimes if you read some technical documents, you might find the word OBSS. And OBSS just basically means overlapping BSS, which is the same thing as co-channel interference. All right, so that brings us to the summary, which is a comparison between 802.11ac and 802.11ax or Wi-Fi 6. So understanding the things that we talked about will put you in a good position to argue about which one is better. And I believe Wi-Fi 6 is a tremendous improvement for wireless communication. So as I mentioned earlier, 802.11ac has the focus of providing high throughput, but unfortunately we never get to achieve the advertised data rates because of all the things that I mentioned in the previous slides. So the 802.11ax or Wi-Fi 6, the main focus of it is high efficiency and better traffic management. And with 802.11ac, you can have theoretical data rate of up to 6.9 gigabits. And you only get that one when you have 160, when you are using 160 megahertz channel, and the access point has 8 spatial, it's actually spatial streams, not special streams. Sorry about that. And something that I hear a lot with voice over IP is that a lot of people, they implement 802.11 for voice over IP, which in my opinion is not a good thing to do, because 802.11ac was designed for applications with higher throughput, which means applications that send large frames or large packets. Voice over IP in general uses small frames, small payload. So when you're using 802.11ac, especially when you increase the channel width to like 80 or 40, or when you go crazy and you put like 160, you're basically not using your frequency bandwidth efficiently. Maximum for me, I usually don't go beyond 40 megahertz 40 megahertz channel width. So for the 802.11, we expect a data rate of up to 9.6 gigabits per second. And of course, you need to have 160 megahertz and 8 spatial streams. So while 802.11ac operates in 5 gigahertz range only, so when 802.11ac came, everybody thought that 2.4 is gone and we're not going to be using it anymore. But we always look at wireless devices from the mobile devices standpoint. And we forgot that there are so many industrial devices that use Wi-Fi, and they work better with 2.4 gigahertz. So 802.11ac is actually going to work with both 2.4 and 5 gigahertz, and it is backward compatible with the legacy standard. So as I mentioned earlier, multi-user MIMO on 802.11ac works only on downstream, while multi-user MIMO on Wi-Fi 6 is supposed to work for both uplink and downlink. And the modulation scheme is up to 256 QAM, which I said allows the device to send up to 8 bits per symbol. And with Wi-Fi 6, now we can send 10 bits per symbol. So we talked about single-user OFDMA, multi-user OFDMA, and I personally believe that multi-user OFDMA is the biggest enhancements in Wi-Fi 6. That's the best thing that they added in Wi-Fi 6. And guard interval, for those of you who have been using GWN, you probably have configured that one. So 802.11ac provides you with 400 and 800 nanoseconds. And with Wi-Fi 6, we're supposed to have up to 3200 nanoseconds. And just to explain what guard interval is, as I mentioned earlier, it's a period of time between symbols. So if you look at the image at the bottom, so every time the access point or the device sends a symbol, there is a guard interval. And the guard interval makes room for the late arrival of symbols when they take different paths in your wireless environment. And so when they take different paths, sometimes they reach their destinations out of order. And so when the packets, they arrive out of order, guard interval works like a buffer. So it's going to wait. So as you can see, it's like the buffer increase from 0.8 microseconds to 3.2 microseconds or 3200 nanoseconds. So this allows the wireless device to increase its buffer. And when it increases the buffer, that means the number of retransmissions that are going to take place in the network are going to be less, because in wireless communication, every time you send something, the other party needs to acknowledge. And that's how it works with wireless communication. All right, so that brings us to the next topic, which is Hotspot 2.0, which is currently on a beta on GWN7600 series. Hotspot 2.0 is a wireless standard that is designed to allow for seamless and secure connection to Passport certified public Wi-Fi. And essentially it allows Hotspot 2.0 capable devices to connect automatically to available public hotspots. And without hotspots, you would usually need to know the SSID and the pre-shared key. And the security issue here is sometimes you do not know the real SSID from the fake one. Plus, it's not seamless to it's not a seamless process of searching for the SSID and entering the pre-shared key. And with Hotspot 2.0, you only need to sign on once to authenticate your device to the authentication server of your carrier using the subscription login details of your carrier. And after you set it up once, your computer will automatically connect to other Hotspot 2.0 networks in the future without the need to do anything. So the registration and the provision will just happens automatically. So now that multiple carriers are partnering together to exchange a database of authenticated users, it is possible now to connect to hotspot networks using different carriers. For example, a user that is authenticated with Verizon can connect to a hotspot network that is using Comcast network. And the way it works, if you look at the image, hotspot 2, by the way, it needs to be enabled on the wireless device. And I'm going to show you later how to enable that one, and how to make sure that your device actually supports hotspot 2.0. So when the wireless station detects an access point or hotspot 2.0 networks, it's going to send the authentication to the access point. Then the access point will forward that authentication to the radius server of the service provider, of the home service provider. And if you happen to be a customer of the same home service provider, it's going to authenticate its own database. And then it's going to send the response to the access point, whether to accept the connection of the device or to reject it. So when the wireless device is already authenticated with the service provider server, it's going to allow it automatically to connect without the need to enter the password or SSID or anything like this. The only thing that is required is you need to register or to sign on to your carrier, as I mentioned. In some places like airports, they use Boingo. You just go to their website and then you create a profile. So once you create a profile, every time you are in hotspot 2.0, your access point is gonna, your wireless device is going to connect automatically. In some cases, when you have carriers that have this authentication database exchange, you can actually take your phone to a different country and still use it, like use the hotspot in that country. So next we move to the security features that were added in the access point. So the first feature is the rogue AP detection. And the way that works is someone put an access point using the same BSS ID. And BSS ID basically is the MAC address of the device. And they create the same SSID as the one in the office. So when users, sometimes they bring their devices to the network and there is a rogue AP, they might end up connecting to the rogue AP. So they will send all their login credentials, and that rogue AP is going to work like a man in the middle. And then all the traffic going from and to or through that access, the rogue access point, will be captured, and you might be sent some sensitive data. And that can be captured using one of those tools. So GWN Access Point now offers this ability to detect in case there is a rogue AP. And the way it detects that, there are a few types that you can choose from. There's the untrusted BSS ID. So when you go to the access point, you configure the MAC addresses or the BSS IDs of your access point in your environment. So when it sees that there is an access point that is broadcasting and it's using a different BSS ID, it's going to detect it, then it's going to send you an alert about that. Also, the spoofing SSID, you can specify the SSIDs that are going to be used in your network. So in case it detects a different SSID, it's going to send you an alert. And this feature is not supported on 7610 and 7602. Firewall is a feature that was added, I believe, in the previous firmware version. So now with the access points, you can actually create firewall rules for inbound and outbound traffic. And this is very useful because something that I notice a lot is that sometimes users, they create a guest network, like a Wi-Fi guest network, but they don't create those inter-VLAN or inter-subnet rules. So users can actually access printers, they can access servers when they log in from the guest network. So now with the GWN76 access points, you can specify the devices that are allowed or not allowed to be accessed from specific SSID. So in this example here, we have a guest SSID where clients, they connect. And then if you have a printer on site or if you have a server on site, you can actually create a rule to block devices to reach those servers or printers on your network. And you can do that based on protocol, or you can specify a specific IP address or a subnet, or you can also include an FQDN if there's a website that you don't want them to access from your network. Let's say people, they come to your guest network and they start watching Netflix. You can actually disable that one, create a rule for it, include Netflix, and then you can deny traffic to that website. All right, so let me see our time. So we still have like 5 more minutes. So I'm gonna go through the web interface quickly just to show you a couple of things. So we talked about Wi-Fi 6. So Wi-Fi 6 is now built into the access point. So this is 7660, and the standard for Wi-Fi 6, as I mentioned earlier, is AX. So it is enabled. You can specify the channel width. Again, if you don't have applications that use like a large payload, you can always go with 20 or 40 maximum. This is 0.4 because you can only have 40, but if you go to 5 gigahertz, you can have up to 80. So I would suggest you stick with 40 megahertz. And the other option is right here. I didn't include that one in the presentation because there's not much to say about it. Yeah, it's right here. So now there's this option that is called 802.11w. And basically this option, when you have it enabled, you encrypt the management frames from the wireless client to the access point. And you have 2 options. You can set it as optional. In other words, if the wireless station supports it, they're going to use it. If they don't, they're not going to use. However, if you use required, that means the device is required to encrypt those management frames. So if the device doesn't support this standard, you're going to end up with some issues. And the way to know whether your system supports this option, you can use the netch command. Let me see if I can get that one here. Show wireless capabilities. So when you use this command on your command line of your computer, it gives you a lot of information about your device. So we're looking for, let me take that one down a little bit here. So we're looking for 802.11w, which is basically, it protects the management frames. It adds confidentiality and integrity to it. And if you go to your computer, it's this one right here. So my computer supports it. So if I force it, my computer will still work. In other words, we're going to encrypt all the traffic going from the management frames from the access point to the wireless station or to my computer. The other option also is like here, ANQP service information. This is for Hotspot 2.0. So when I see that one here, I know that my computer supports it. And if I go to my network settings, let me bring that one here. And if you, there it is. There's the Hotspot 2.0 networks. So when you set that one to on, and if you are sitting in a network that supports Hotspot 2.0, it's going to show you the list of the carriers. Then you're going to choose the carrier. Then you're going to enter the subscription login details of your carrier, so your computer can authenticate with your carrier authentication server. Once you do that, next you don't have to do it anymore. You can go anywhere where they have Hotspot 2.0 and your computer will connect automatically. You can also use the other command. Show driver, I believe. Yeah, show driver. So this command right here, it tells you which standards are supported on your computer. So if you are using, if your computer supports Wi-Fi 6, you're going to see 802.11ax. So mine doesn't support Wi-Fi 6 yet, so that's why it's not showing here. The next thing quickly before we, let me go back to 7600. So Hotspot 2 is still in beta. This is where you configure it. And hopefully in the near future, we're going to have a webinar dedicated specifically to this feature because there are a lot of settings that you need to configure and we have to explain what each one of them does. So hopefully in the near future, we can host a webinar specifically about Hotspot 2.0 and explain how it works and how to configure it. So we have a few more minutes. So I'm just going to go through the Q&A section and see if we have any questions. So I see a lot of people posting questions in the group chat instead of the Q&A section. So someone is asking about will the upgrade of the access point support Wi-Fi 6? No, Wi-Fi 6 is a new hardware, is a new chipset. So you're not going to get to Wi-Fi 6 just by upgrading the device. You need a new device, a new chipset that supports Wi-Fi 6. You can't get Wi-Fi 6 just by upgrading the software of your device. Okay. No, the same question again, is Wi-Fi 6 available in new firmware? No, Wi-Fi 6 again works only with the new hardware. What about Wi-Fi 6 supported models? So I mentioned earlier during the presentation that Grandstream will release the GWN7660 within a month or two, and that's the model that's going to support Wi-Fi 6. Sufyan, I tried to use it in, I'm not sure what you tried to use on GWN7610. If you can specify that or confirm. Are the 7660 available right now? As I mentioned, they're going to be available or they're going to be released in a month or two. So most likely next month or the beginning of April. And the number of antennas is 2 by 2. So let me go back here because it looks like some users didn't attend the beginning of this presentation. So these are the specifications related to GWN7660. Eliran is asking, what about 4x4? Yeah, this is the first model. There are still more models coming, and some of them might also have 4x4 antennas. Yeah, Gal is asking, I would like to register for the way. So we haven't announced when we're going to host this webinar for Hotspot 2.0. You can always go to the Grandstream website and check the upcoming webinars. And we're going to include the dates in there so you can register for one when we host it. No, the same question. Can the existing 76 and 7630 use Wi-Fi? No, you need a new hardware. Even your computer, we need a new hardware. And iPhones also, we need a new hardware, Android. So it's always, it's about the chipset. If your chipset doesn't support Wi-Fi 6, a software upgrade is not going to make the device supports Wi-Fi 6. So you need a new device with a new hardware. Where can I get a record of this webinar? So as I mentioned, this webinar is recorded and it will be posted on the Grandstream YouTube channel. You can always go there and you can watch it. We will post it either tomorrow or the day after. So with that, I think we've covered everything. Again, thanks everyone for taking the time to join us today in this webinar. And I hope to see you in one of the upcoming webinars, and stay safe, and I'll see you next time. Have a good one.